Thank you everybody for coming today. My name is Natalie Cole. As Claudia said, I'm a lecturer at Birmingham City University on the Product and Furniture Design course. And my area of research is bio-based regenerative materials and scales of production. The research is still in its early stages, but I wanted to share my first case study from it. So it's commonly accepted that we are using 1.5 planets worth of resources every year. Our demand is outstripping supply by 8 billion. And we've been following this linear take, make, discard model since the Industrial Revolution. And the negative impact that it's having is irrefutable, I think. Not only are we running out of resources to make things with, but we are also running out of room for all the waste that we're generating. And of course, all that waste is polluting our lands and our seas. But what if the material we were to use were not finite? What if the more material we used, the better it was for the planet and the environment? And biodegradable regenerative materials could potentially be an answer to this. Regenerative materials are made from plentiful sources of natural ingredients, such as abundant plants or crops or agricultural waste. They are biodegradable, so they break down to feed nutrients back into the soil at the end of the product's life, creating a closed life cycle rather than a linear one. And there are a growing number of examples that exist of bio-based materials, but mostly used in artisan and craft objects. But a lot less have taken that leap into scaled up production. And this is the area that I'm focusing on, because I believe that if biomaterials are going to have an impact, we need to find methods of producing objects in quantity. So there's a growing number of materials, biomaterial recipes being shared online and open source platforms. And the website Materium, which is what this screen shows you, is an amazing resource where material designers share their recipes and basic instructions so that anyone can make the material at home in their kitchen. But with this new generation of materials, methods for working with them need to be developed. We obviously have large amounts of knowledge and reference material and data that exists in relation to processing traditional materials, but understandably there is a gap when it comes to new biomaterials. So beginning with eggshell composite ceramic, my aim is to look at a series of biomaterials to determine if they have the potential to be used in mid to large volume batch production or potentially even mass production processes. So my approach for selecting the first recipe wasn't overly scientific, but it's quite a nice story. The material was developed by an industrial designer and materials researcher called Madushi Kocher, and she made the recipe available online on the Materium website. She's based in New Delhi in the Netherlands and is the founder of YLEM, a circular design and research studio. And the first prototype she made from the material was her eggware range, which featured disposable plates and cups for street food. And since then, Madushi has developed a range of products using the material, as well as developing other biomaterials as well. But to date, her focus has been based on craft processes and small-scale production. Just to tell you a little bit more about the material itself, it contains only 3 ingredients: eggshells, which are an agricultural waste byproduct, alginate from brown seaweed, which is an abundant natural crop, and water. And the resulting material is completely renewable, non-toxic, and at the end of the product's life, it completely biodegrades. And no specialist equipment is required to dispose of the product. You can simply add it to the soil and it biodegrades, and the bionutrients feed the soil, closing the loop. Existing manufacturing methods, technologies and infrastructure for traditional materials processing, and these initial explorations allowed for approximate recreations of what happens in industry before moving on to more refined tests. So one of the most successful methods of working with the material was compression moulding. It's a process already used for forming several different types of material, including rubbers, ceramics and thermoset plastics. The process in industry generally starts with granules, but for me, I was using the viscous, thick liquid material in that state when it was moulded. A 2-part male and female mould is used, which creates the form. This means it's suitable for simple forms with no undercuts. The process is ideal for producing parts that require large, thick-walled solid sections, although it is a little limited in terms of the complexity of the object that can be achieved. But I just wanted to demonstrate some of the properties. So that is, that plant pot is me standing on it upside down. So it can take a substantial amount of weight. So in particular orientations, it is very strong. Compression moulding was also used to make this clock from the eggshell material. Just to give you an idea, there's about 130 eggshells in one of those clocks. Injection moulding was also looked at. This is a process obviously normally used for plastics. So to replicate this, I used pressure to inject the material into the mould. There were quite a lot of challenges in terms of the viscosity of the material and the air bubbles, which you can see in that image along the bottom. But nevertheless, I think there probably is potential to explore it a little further. Another process I tested was ram moulding. This is generally used in the ceramics industry for mass producing tableware. A 2-part mould is used again. Under high pressure, the top part of the mould is pushed down onto the bottom part. The top of the mould has a cutting edge to it. So the lower mould is charged with the material. The 2 moulds are forced together under pressure. And then within 2 minutes, the material set and the mould is opened. And that cutting edge on the mould means that any flashing can just be peeled away and removed. The final bowl removed from the mould is simply left to dry, and you can see sort of multiple samples there on the side of experiments that I went through trying to work out the correct consistency for the material and how to avoid air bubbles in the moulding process as well. So as well as those 1-stage production processes, I looked at some 2-stage methods because of the material's unusual properties. So the first stage here was to cast a thin disc, a thin circle of the material. Once it had gone to its set rubbery state, I then slumped that disc over a second mould and left it to dry, taking on the form of the second mould. And these are some other examples doing similar kinds of things, casting a sheet of it and then slumping it over a secondary mould to take on another form. Through the experimentations with the material, it's really clear that there's a lot of interesting properties to the material that could be exploited through the design process to create biodegradable products and furniture. Both the ram moulding and the compression moulding showed potential for larger volume production methods and are worth pursuing further, ideally, I think, through a collaboration with a manufacturer to test this. There is still quite a long way to go, though, to get there. And although these initial results show that technically it might be possible to use established production methods, there are lots of challenges as well. Preparation of the eggshells is a key stage in the production of the material. And the shells all require boiling, then drying, and then milling before they can be used. And whilst machines do exist on an industrial scale to do this, a number of UK-based egg breaking companies have stopped using the kit. I've been in contact with 3 different companies who all used to have the equipment but no longer use it because of the impact in terms of the energy usage. Of course, another obvious challenge is trying to find companies willing to take on board the risk of developing their assembly lines to accommodate the steps required to bring the 3 ingredients together. It's very different from the processes in ram moulding that go on before the material gets placed in the mould. In fact, the steps used to prepare the material probably have more in common with mass producing food. So I think that's probably an area to explore as well. So my next steps with this project, an important part of my research is sharing it. I only found out about this recipe through somebody else sharing their work. I want to continue to do that so that we build the knowledge and share the knowledge rather than keeping it to ourselves. So one of my intentions is to begin a dialogue, hopefully with Materium, to see if there's any possibility of sharing that manufacturing information on the website alongside the recipe information. I also want to do some further work with the RAM process and hopefully collaborate with a manufacturer to see if it can be done in production. And finally, I need to find a second material to start to look at after I've finished with the eggshell one. So if anybody has any recommendations for materials, please let me know. If anyone is interested in any of the stuff I've been talking about, and you want to know more, or you want to collaborate, or you've got knowledge you want to share, please do get in touch. And my email address is there. Thank you very much for your time and attention this afternoon.